Projectile fired at an angle with horizontal. In this class we have discussed when an object is thrown from the top of a tower. Now, in this topic, we'll discuss the motion of particle along I mean when we fire or we throw upward in this part, in this way. So similar to the previous topics, I'll try to derive the equation of motion, and suppose here, let me zoom out, zoom in, and suppose at initially the particle is at O here, and that particle is projectile or fired upward in this direction, and initially the particle is moved in a straight line for a moment, and after a few seconds it will fall down back to the ground and follow parabolic path. It is clear from the picture, the diagram, so we'll prove this one in mathematical form. So at any time t, suppose a particle is at point P, we'll consider when the particle reaches point P. At point P, the displacement along horizontal in this direction is x, and its velocity is ux, and velocity along y direction will be here uy, and the maximum height a particle can reach is 8. Here is 8, and here y is the displacement along y-axis at any time. Here we'll take at point P. Point P, height of point P from the ground is y. So let me draw another diagram. This is horizontal line, this direction, and this is initial motion along straight line, and if here is point P, here's point P, and the angle between initial motion, line of motion, and horizontal is theta. So I have ux here, and initial velocity is u, so I can find ux. This is y. So ux will be, let me take cos theta first. I can take sine theta. Cos theta is based by hypotenuse. So here I have base here. Base is ux. Hypotenuse is u. So ux will give u cos theta. I have it. That is here. So the velocity along horizontal will be u cos theta. So the velocity of horizontal is depends on theta. Theta is the angle between the initial part and the horizontal line. So initially ax means horizontal path. Horizontal path has acceleration 0 because acceleration due to gravity is 0 in horizontal. It always acts along vertical. So in horizontal, ax must be here 0. I have 0 here. So from the equation of motion, x equal to, here it is missing t. We have t, uxt plus half at square. Here a is 0. Yeah, we have 0 here. So we'll put 0, and instead of ux, we'll put this one, u cos theta. Here's u cos theta, and I have t. Here's t. The text it is missing. So this term becomes 0 here, now 0. So I will have only this term. So I will find t, this ux cos theta. If I transfer to the left side, it will become goes to divisor part. So t will give x by u cos theta. I have this one. So in kan ma kan tiang thâu kan dang lam naum lao. So we have value of t here. So we'll find equation of motion along vertical. That is motion along horizontal. Motion along horizontal. Equation of motion along horizontal will be this one. This is displacement x is displacement along horizontal here. At any time t, here we take point P. So motion along vertical will be uy. We'll find uy here. In the previous case, we'll do sine theta. If I take sine theta is perpendicular by hypotenuse. Here is a straight line. So straight line here is y. Perpendicular. Perpendicular here. In terms of velocity, that will be uy. So uy by uy by u base perpendicular by base is sine theta. So uy equal to u sine theta here. So I have velocity along y-axis. Where is it? Here we have it. So the particle moves upward direction, in upward motion at point P here. So in upward direction, acceleration due to gravity will be negative of g, as we have discussed. So Ly will be g minus g. So from equation of motion along y-axis, y equal to u yt plus half Lyt squared. So we have uy here. Yeah, we have uy. So instead of uy, we'll put u sine theta here. So u sine theta here is uy. So instead of Ly, we'll put minus g here. So if we solve, we'll get this one. So this is equation of motion along y-axis. Now equation of trajectory. Trajectory means, as we have discussed, what is the path of these particles that it follows. So we want to find which path it follows. So from equation of motion, we have here, we have t. Where is t? From the here, we have t here, and then we put value of t to this one, and here also. So if I put t, I have t equal x by u cos theta. Here is also is t, but it's whole square. So here is sine by cos theta is tan theta. I have tan theta. U and u, they can cancel out. So I have tan theta. Where is x? Here I have x here. So x tan theta, I'll get this one. So minus, this is minus. So I have minus here. Then we'll square all these. We'll square all these. If I square it, that will be x squared. Here I will get x squared. So u squared cos squared theta. So I have g by, here is 2. Now if it is square, you become square cos square theta into, I have x here, x. So if I put inside bracket, I get these terms. So this is square. If it is square, like in the first case, the path followed by the particle will also be, here will be parabolic. A parabolic anh ti kan lo proof leta khala proof te kha ka sei to kha lo chin chia keu zero he po not lo siam tur ani. So now the main part, the most important part is time of flight. That means how much seconds a particle takes from this point to fly and reach point Q. Here is, I have Q here, Q is the ground. So time of flight, I'll find time of flight here. So how will you find it? Time of flight, equation of motion, U equal to, for the equation of motion, V equal to U plus at here, or suppose G or at square. U plus, no, just at. In the previous classes, we have already discussed this one. So V equal to V, here is V is in Y direction. I'll find up to this point the time it needs by the particles, that is in upward direction. So velocity will be Vy, Vy divided by Vy, here in Vy, that will be Uy, that is Ay. So we'll put it here. Uy is U sine theta. Here we have it. That is U sine theta. Instead of Uy theta. Initially, the particles does not move along y-axis at origin. Here, that is Uy is 0. So Vy is 0. So I have Vy equal to 0. Uy will be U sine theta, and here I have it here, so plus theta Ay, instead of Ay G among theta, because the particle moves upwards. So I have T, total time of flight. If the total time of flight is T, so this point will be the half point, the half part. So this, in this part, the time required is T by 2, half, and this also is T by 2. So I'll find T by 2. So instead of T, for T, I'll get T by 2, because the total time required is capital T. Here I will find only the half part, so I will divide it by 2. So if I transfer and I solve it, I'll get this one. It's a simple thing. You can find T, a transfer equal to 0 loading G here on divide nga 2 multiply me 2 multiplier G divide kakan loading that is the total time of flight it takes from the beginning to when it turns back to the ground. Time of flight and maximum height attained, reached by the particle. We have maximum height. The height is in Y direction, not X. In X is horizontal, just the ground. So we'll consider along y-axis. So maximum height means distance, displacement. So equation, we'll use equation of displacement. Y equal to, here y equal to uyt plus half at t square. This is the same thing as the previous. I have uy, I have t instead of t. I want to find maximum height. Maximum height is the half point. So instead of t will be equal to t by 2, and capital T is total time takes. So instead of t, I'll put t by 2 here, and t by 2, if I divide t by 2, here 2 will not be there because it comes to this position. U sine theta by g. I have u sine theta by g. Then y will be maximum height, so it will equal to h. So instead of y, I'll put h here. then uy, this is uy, this is t, this time is t plus half minus g, minus ni chen chu upward direction kal wang yang, this is t, here is t, here also is t. Then if you solve it, you can find this maximum height attained. This part is important. Mark it as VIP and derive it. So do not direct this point. Solve step by step and get this one. If you cannot get the answer, you can ask me. Dikhan nita se one horizontal range. Horizontal range means the total displacement covered by the particle. If I say the total distance, I will measure the path along this particle. And if I say the total displacement, I will measure the distance between this and this only. Projectile, I will take the horizontal distance here. So horizontal range, this horizontal distance, this is r. So I will not derive this one. I think you can derive it, but it's not necessary to derive. I'll x this one, but we have to know the formula. This one, horizontal range, and this is maximum height. We have to know clearly this one. So on maximum horizontal range. Maximum horizontal range. Here also we have to know that one. Remember, not in notebook I was zero. Kaka kantenga. So on. Next one we'll go through the problems. As I already said, the problem itself is a problem for us. So we'll find that problems, and I think we'll win. We'll win. Kasi itong kan problem kan overview doon. Masa problem titur point kami holo chuan teka. Engmo idea tal kan nei lo chuan kan ti lei thi don chuang lo ta ne. Chu wangin kami derivation ho teka lo zir le ta ula nakina engmo thim lo nei chuan rengani teka. And so you don't let do again. Have a nice day.